From the moment human beings first looked up at the night sky, we have wondered if we are alone. Are the countless stars scattered across the heavens home to other forms of life? Or is Earth the only island of biology in a vast cosmic ocean? This is more than curiosity. It is a question about identity and destiny. If life exists elsewhere, it could change how we see ourselves, our place in the universe, and even the future of our civilization. Modern science is now closer than ever to answering this question. With powerful telescopes, robotic explorers, and deep space missions, we are searching for signs of life beyond Earth. From the planets of our solar system to the thousands of exoplanets discovered around distant stars, the evidence is growing. This journey will explore what scientists know, what they hope to find, and what it would mean if we discovered that we are not alone. Let us begin the search. Before we can search for alien life, we must understand the conditions that make life possible. On Earth, all known organisms share certain requirements. First, they need liquid water. Water is the universal solvent. It allows molecules to mix, react, and form the chemistry of life. Wherever water flows on Earth, life is present, from tropical oceans to frozen glaciers. Second, life requires energy. On Earth, energy comes from the sun through sunlight, or from chemical reactions deep underground. Energy drives metabolism and powers the complex machinery of living cells. Third, life needs the right chemical elements. Carbon is the foundation of organic molecules. Nitrogen, oxygen, hydrogen, phosphorus, and sulfur provide the building blocks for proteins, DNA, and cell membranes. Finally, life requires stability. A planet or moon must have conditions that allow these ingredients to persist for millions or billions of years, giving life time to evolve. When scientists search for life elsewhere, they look for these 4 factors: water, energy, chemistry, and stability. These are the universal signposts of habitability. But could life exist in forms very different from our own? Some researchers suggest that alien biology might use alternative chemistries, perhaps based on silicon or liquid methane. These ideas remain speculative, but they remind us that our definition of life may need to expand. The search begins with what we know from Earth, but it may end with discoveries beyond our imagination. For more than a century, Mars has captured the human imagination. It is the closest planet where life beyond Earth might exist, and it has been the focus of countless missions. Mars today is cold and dry, with thin air and a surface battered by radiation. Yet scientists believe it was once very different. Billions of years ago, Mars had rivers, lakes, and even seas. Evidence from orbiters and rovers shows valleys carved by flowing water and minerals that only form in liquid conditions. The NASA rover Curiosity discovered organic molecules in Martian rocks, molecules that are the basic ingredients of life. The Perseverance rover, which landed in the Jezero crater in 2021, is searching for fossilized signs of ancient microbial life. It is also collecting samples that future missions may return to Earth. If life ever existed on Mars, it may have been simple microbes that thrived when the planet was warmer and wetter. Some scientists believe life could still exist underground, where water and heat might remain. The discovery of even the simplest fossil microbes on Mars would be revolutionary. It would prove that life is not unique to Earth, but a natural outcome of planetary evolution. Mars may hold the answer to one of humanity's greatest questions, and we are closer than ever to finding it. Beyond Mars, some of the most promising places to look for life are the icy moons of the outer planets. Though their surfaces are frozen, beneath the ice lie vast oceans of liquid water. Europa, a moon of Jupiter, is one of the most compelling candidates. Cracks in its icy crust suggest that a global ocean lies beneath, kept liquid by the tidal heating from Jupiter's gravity. The Hubble Space Telescope has detected plumes of water vapor erupting from Europa, providing a way to study its hidden ocean. Enceladus, a small moon of Saturn, also hides an ocean beneath its icy shell. In 2005, The Cassini spacecraft discovered geysers shooting water vapor and ice particles into space. Analysis showed that the plumes contain organic molecules and hints of hydrothermal activity on the seafloor. This is similar to environments on Earth where life thrives around deep sea vents. Other moons, like Ganymede and Titan, also show signs of oceans. Titan, with its thick atmosphere and lakes of liquid methane, could host exotic forms of chemistry that might resemble life. These ocean worlds remind us that life does not require Earth-like surfaces. It may exist in hidden seas beneath the ice, warmed by tidal forces and fueled by chemical energy. Future missions, like NASA's Europa Clipper and the European Space Agency's JUICE mission, will explore these moons in detail. If life exists in their oceans, we may soon find the evidence. Just 3 decades ago, the existence of planets around other stars was only a theory. Today, astronomers have confirmed more than 5,000 exoplanets, with thousands more candidates awaiting confirmation. These discoveries have transformed our view of the universe. Exoplanets come in astonishing variety. Some are gas giants larger than Jupiter, orbiting so close to their stars that their atmospheres boil. Others are rocky worlds similar in size to Earth, orbiting in the so-called habitable zone, where liquid water could exist. The Kepler Space Telescope played a key role in this revolution. By observing tiny dips in starlight as planets passed in front of their stars, Kepler revealed that planets are common. In fact, there may be more planets in the galaxy than stars. The search now focuses on Earth-like exoplanets. The James Webb Space Telescope can analyze the atmospheres of some of these distant worlds, searching for gases like oxygen, methane, and carbon dioxide. These molecules, if found together, could be signs of biological activity. Planets like Proxima Centauri b, orbiting the nearest star to the Sun, and TRAPPIST-1's 7 Earth-sized planets, are prime targets. If even one of them shows signs of habitability, it would suggest that life may be widespread in the galaxy. Every exoplanet discovered is a new opportunity, a new laboratory, and a new piece of the puzzle. The more we find, the more likely it seems that we are not alone. Finding planets is only the first step. The real challenge is to detect life. Scientists look for biosignatures, the chemical fingerprints of living organisms. On Earth, life alters the atmosphere. Plants release oxygen. Microbes release methane. Oceans absorb carbon dioxide. Together, these processes create a balance that is unlikely to occur by chance. Astronomers use spectroscopy to study the light from distant planets. When starlight passes through a planet's atmosphere, it carries information about the gases present. By analyzing this light, scientists can search for signs of oxygen, water vapor, or other molecules linked to life. But detecting biosignatures is not simple. Oxygen, for example, can also be produced by non-biological processes. Methane can come from volcanoes as well as microbes. Scientists must be cautious, searching for patterns that strongly suggest biology rather than geology. Future telescopes, like the proposed Habitable Worlds Observatory, aim to take direct images of Earth-like exoplanets and analyze their atmospheres with precision. With these tools, we may soon be able to identify planets that not only look like Earth, but breathe like Earth as well. The discovery of a true biosignature would be one of the greatest milestones in history. It would mean that life has arisen not once, but many times, across the universe. Chapter 6. The Search for Intelligent Life. While microbial life would be a profound discovery, many wonder about something even more dramatic: intelligent civilizations. Are there beings out there capable of thought, communication, and technology? The search for extraterrestrial intelligence, known as SETI, has been scanning the skies for decades. Using giant radio telescopes, scientists listen for signals that might come from other civilizations. They search for patterns in radio waves or laser pulses that could not be explained by natural sources. So far, no confirmed signals have been found. But the search is only beginning. The galaxy is vast, with hundreds of billions of stars. Even if intelligent life is rare, The sheer scale means it could still exist in many places. One famous example is the WOW signal, detected in 1977 by a radio telescope in Ohio. The signal lasted only 72 seconds and has never been repeated, but it remains one of the most intriguing mysteries in the search for alien life. Today, projects like Breakthrough Listen use the most advanced technology to scan millions of stars. They search across wide ranges of frequencies and collect vast amounts of data, using artificial intelligence to analyze the signals. The discovery of intelligent life would not only answer the question of whether we are alone, it would also show that civilization is not unique to Earth. It would open the door to questions about communication, culture, and the future of advanced species. If the universe is so vast, and if planets are so common, then why have we not found evidence of life? This question is known as the Fermi paradox, named after physicist Enrico Fermi, who asked, "Where is everybody?" There are many possible answers. One idea is that intelligent life is rare. Perhaps the conditions needed for complex civilizations are far less common than we think. Another idea is that civilizations do not last long. They may destroy themselves through war, resource collapse, or environmental disaster before they can spread among the stars. It is also possible that alien civilizations are out there, but too far away for us to detect. The Milky Way galaxy is 100,000 light-years across. Signals could take centuries or millennia to travel. Some scientists suggest that advanced civilizations may deliberately avoid contact, practicing what is called the Great Silence. Others believe we may not recognize their signals because they use forms of communication beyond our technology. The Fermi paradox is not just a scientific puzzle. It is a reflection on humanity itself. If civilizations tend to self-destruct, what does that mean for our future? If they can survive and thrive, then perhaps we too can find a path to longevity among the stars. The paradox forces us to consider both the possibilities and the responsibilities of being an intelligent species in a vast and silent universe. The discovery of life beyond Earth would be one of the most transformative events in human history. Even the simplest microbe found on Mars, Europa, or an exoplanet would prove that life is not unique to Earth. It would show that biology is a universal process, not a cosmic accident. If we found evidence of intelligent civilizations, the impact would be even greater. It would raise questions about communication, cooperation, and the diversity of ways life can evolve. It could inspire new philosophies, new technologies, and a new sense of unity for humanity. But the discovery would also challenge us. How would religions, cultures, and governments respond? Would we see ourselves as one species among many, or cling more tightly to old divisions? The search for alien life is not just about science. It is about who we are and who we might become. Whether we find microbes in a Martian rock, fish swimming in Europa's ocean, or a signal from the stars, the message will be the same. We are part of a living universe. Closing. The question of whether we are alone has echoed through human history. For centuries, it was a matter of speculation. Today, it is a matter of science. We search Mars for fossils of ancient microbes. We probe the icy moons of Jupiter and Saturn for hidden oceans. We study exoplanets, scanning their atmospheres for the breath of life. We listen to the stars for voices that may be calling across the void. The silence so far does not mean we are alone. It means the search has only begun. The universe is vast, and our tools are just now powerful enough to explore it. Perhaps tomorrow, or in 10 years, or in 100 years, we will find the evidence that answers the question. Until then, the search continues. As you look at the night sky, remember this: every star may hold a story, every planet may hold a secret, and somewhere, life may be waiting. The search for alien life is, in the end, a search for ourselves. To know if we are alone is to know our place in the cosmos. This is the search for alien life, and it is a story humanity is destined to finish.